Hi everyone, I'm just going to give you a few tips for getting your assignment finished off today. There might be a few parts of the assignment that are a little confusing to you, so I figured I'd give you a refresher on some of the, more obscure aspects of some of the questions I'm asking on that assignment. So we'll start by just reminding you of a few things related to torque. For example, you might be good with angular kinematics, but you might forget that torque, which is the sort of the effect of a force has when creating a rotation. Torque is equal to inertia, rotational inertia, that is, times angular acceleration. So if, for example, on number 2C, it says if the disk has a rotational inertia of 0.23 kilograms per square meter, kilograms meters squared, what torque was required to create the acceleration? So for a problem like 2C, all you have to do is you have your torque right here. So if you want to calculate your net torque, you're going to simply plug in your inertia and then multiply by the acceleration you got from part A. So that's pretty straightforward, and you're going to do that in several other parts later on in the worksheet as well. So just keep in mind that if it asks you how to calculate the torque, you can always multiply your rotational inertia by your angular acceleration to calculate your net torque. So that's the first thing. After that, you can also say maybe they might ask you, what the angular momentum would be. And angular momentum actually is somewhat similar. The angular momentum is equal to, we call it rather L, and it's just equal to the rotational inertia times the angular velocity. So if you have the inertia and the angular velocity, you can just multiply those two together to get the angular momentum. And so that was, say, 4D, they ask for the angular momentum. And maybe, you haven't looked at that since the very beginning of the unit where we introduced some terms. So it might be worth remembering and being reminded of that. So with that said, the other thing that I wanted to make sure that I reminded you of or introduced you to is the idea of relating angular and linear quantities to each other. And those, it's relatively simple, but for example, if you have a wheel rolling along the ground, so say the wheel is rolling, in this case, clockwise, then your wheel is going to have some angular velocity. It's going to have a radius, r, and the wheel is therefore going to travel a certain distance, which is equal to its circumference for every time it rotates. So as the wheel rotates, it happens to travel one circumference, so 1c per rotation. Okay? Now that is something to keep in mind, but we can sort of generalize some things related to how the wheel moves into some basic equations, okay? So the first thing is to understand that circumference is equal to 2 pi r, which we can go ahead and write backwards. We're going to write r times 2 pi, and there's actually a reason for that, because instead of being specific about the circumference being one full rotation, you can generalize this equation here, and you can find the distance, so to speak. I know we're using delta x here, but that's fine. We can find the distance right here that the wheel travels by multiplying r times any angle, okay? So it doesn't have to be a full rotation. So if you know the wheel travels pi radians as an example, then it's going to travel half of a circumference. And if you know it travels pi over 4 radians, then it's going to travel, an eighth of a circumference. So the point is that there's this general formula right here can be used to find the distance and a wheel travels for any amount of rotation, whereas the equation on top here, the formula for circumference, is specific to one full rotation, which is 2 pi radians. Now, from this equation, we can derive or find a few other equations, namely that the linear velocity of the wheel is going to be equal to the radius times the, angular velocity, omega. So V equals R omega, or RW, or R wumbo, however you want to say it. And so this can be, you can actually get this equation right here from the one above it simply by dividing both sides by the time. So if you divide both sides by time, you get velocity on the left, and if you divide both sides by time, you get angular velocity on the right. And they're just related by r. So if it asks for a linear speed for the wheel, what that means is you simply are, you're going to plug in your angular speed and your radius and multiply those two together, and you'll get your linear speed. So just keep that in mind. And then I think that's about all it is that we're going to do. We'll talk a little bit about 5C real quick. 5C says calculate the distance traveled by the wheel during 1 minute. And essentially that's just, going back to our good old simple equation, displacement over time for velocity, or distance over time for speed. So if you know how fast, and you know that it's traveling for 1 minute, or of course 60 seconds, then you can plug in your speed for your v and your time 60 seconds for your t in order to find the distance or displacement delta x. So just keep that in mind for 5C. So that's a pretty quick and succinct video to just sort of help you figure out some things. And oh, you know what? I just noticed on 5E, I do need to give you one more equation. So sorry about that. If we actually take this equation right here, and we divide both sides by the time one more time, then we end up with A equals R times alpha. And so if you know the angular acceleration alpha, you can multiply by the radius in order to get the linear acceleration. So I promise that's actually it. Sorry about that. I forgot you needed that one. So anyway, that hopefully will help you guys finish off the latest assignment, Rotations Practice 1. As always, feel free to hit me up on Google Hangouts or email to ask questions, and if we need to, we can video chat. So have a great Tuesday, guys.